question, we're going to describe and sketch the vertical and horizontal traces of f of x comma y is equal to x squared plus 4y squared. Okay, so for vertical traces we have two. We should have two of them, and for horizontal there would be one kind of trace, anyways. Okay, so let's start with freezing x at a. Okay, so vertical trace at x is equal to a. So let's see what happens when we plug that in. If we plug in an a for the x spot, we get f of a comma y, which is also our z, right? The z of our surface is going to equal, which is the height, a squared plus 4y squared. Okay, so here we have something, a is a constant, right? So that kind of is just there. There's no more x variable. So we have a function of y that determines our z, that determines our height. So this is basically, this whole form here, that's I'll just write it again. So z is equal to a squared plus 4y squared. So this is actually the formula or the equation for a parabola. Okay, so this is a parabola, and in which plane? This would be in the yz plane. Okay, because we still have those there. So yz plane. Because if y changes, then z is going to change. Nothing depends on x anymore because we set x to a constant. Okay, because we froze x. Okay, so what would this look like? We'll draw a little sketch of it. So this is going to be something, again, it's a parabola in the yz plane, or by in I mean like parallel to. Okay, so anyways, if we set x equal to some a, so here's our plane there, x equals a, so this is parallel, so parabola parallel, I'll fix that, parallel to the yz plane. Okay, so anyway, so we have some parabola, and this is upward facing because there's a positive in front of the y squared, so it would look something like that. Okay, or maybe even more so. This is just a sketch. Okay, so this is in the plane x equals a. All right, so now let's freeze our y variable. So let's say we have so again, here's our function. So we have f of x y is equal to our x squared plus our 4y squared. Okay, and now we're going to freeze y at b, let's say. So if we do that, then we get that our f of x comma b, which is going to be our height, our z coordinate, this is going to be equal to x squared plus 4 times b squared. Okay, if we plug in a b for our y. So this will give us z equals x squared plus 4b squared. So this part here, that's just a constant, right? This whole term, because b is a constant. And then again, we see a z is equal to something squared. So this again is going to be a parabola, but this time it's going to be parallel to, I'm not going to say in anymore, so parallel to the xz plane, okay? Because when x varies, or when it shifts, then z will shift as well. It'll change as a result. Nothing depends on y anymore because we froze that, right? So we froze our y variable. So let's see what this one's going to look like as a sketch. So we have our x, our y, and our z, and we froze y at some constant b. So this plane is going to look like, pretend that's a vertical line, please. Anyway, so something like that, right? So this is our y equals b plane, right? The one that I just drew. And this is a parabola parallel to the xz plane. So this is going to be a parabola, and it's going to be kind of like turned sideways, right? It's parallel to this plane over here. Okay, so that's our the sketch of our other vertical trace. Okay, and now let's move on to the horizontal trace. So horizontal trace, and again, this horizontal trace, this is obtained by setting our z, our height, equal to a constant, right? So our constant, z was equal to our f of xy, which was a given as x squared plus 4y squared. Okay, so we're saying, so these are all equal, right? So this c just came from because we are trying to calculate the horizontal trace, and this other stuff, that's all kind of, we've already worked with that. So anyways, the important part here is that we have c is equal to x squared plus 4y squared. So we have some constant over here, some number, is equal to an x squared plus a y squared something or other. So what that means for c is greater than 0, what we have is the equation of actually an ellipse, right? Equation of an ellipse. Ellipse. Okay, so here that would actually look like something x, y, z, okay? And this ellipse is actually going to be parallel to the xy plane. That's the only plane that we had left, right? Because we already used the xz plane, we already used the yz plane, and now we just need the xy plane because our traces or our plane was cutting across this way, like horizontally, right? So we had c equals something there. But anyways, okay, so let's say I'll just remove that plane for now. Okay, let's say we had some kind of graph, and we know that in the xz direction on that plane we had some kind of parabola going on. In the YZ plane, we had some kind of parabola like that going on, okay? And then we'll have these going again. So it looks kind of like a weird shaped bowl, right? So it's some kind of bowl. And now we know that at one height, let's say C is here, okay? So here's our plane now, right? And then we'll just draw like dashed lines there. Okay, so here's our plane, and this is going to cut through at an ellipse, okay? So something like that. So if we were to view this from the xy, on the xy plane, it would look like an ellipse like that or something. Okay? So that's a sketch of it, and that's pretty much it. So that was our horizontal trace when we set z equal to a constant, and we calculated the vertical traces, one at x equals a and the other one at y equals b. Okay? So that wraps it up for the practice problems video for the section on functions of 2 or more variables. I hope that helps, and happy studying.